Hello students, in this session we are going to study the simply supported beam with point load using the conjugate beam method. Our aim is to find out the deflection and slope, maximum deflection and maximum slope using the conjugate beam method. So what type of slope will be there? This is the elastic curve obtained for a simply supported beam when a point load is applied at the center. So point load is applied at the center and we are getting the maximum deflection at the center. So our aim is to find out this maximum deflection, and the slope is maximum at the supports, right? So theta max. So we have to find this maximum slope and maximum deflection, right? Which is obtained at the A point and C point, right? So what is conjugate beam? First we have to draw the conjugate beam. Conjugate beam is that beam, for simply supported beam, the length will remain same, the supports will remain same. The difference is that the roller joint will become hinge joint and hinge joint will become roller joint. That's it. Otherwise reactions are same, supports are same, right? Like here there are some reactions, similarly there will be reactions. So need not to show the supports, we can show only the reactions, right? And it will be having a width of EI and the loaded with bending moment diagram. So first we have to draw the bending moment diagram and then we can make the conjugate beam. So what is the bending moment diagram of this simply supported beam? So bending moment diagram is like this. This is our beam and you can draw the bending moment diagram taking the section. We already done many times this thing, and the bending moment diagram will be like this. You can see in the shear force and bending moment diagram chapter, you can see here, and this height will be WL by 4, WL by 4, where L is the total length of the beam, L is the length of the beam and W is the load. So this height, maximum height, is a WL by 4, right? And now it will become a conjugate beam. Now this bending moment diagram is this. Now this is a conjugate beam loaded with this triangle area, right? And this is the load, means this is the variable load, right? And here there is some reaction at point A. Suppose A point will remain A, B point will remain B. Simply supports are there, so simply supports are there. The difference is that the roller joint will become hinge joint and hinge joint will become roller joint. That doesn't make a difference until unless there is any horizontal load, so there is no problem in that, right? So this is the conjugate beam. Now it is loaded and at these points A and B, and there is reaction from the supports. Support A and support B is creating reaction. So this RA and RB will be equal to the load applied. Half will be, because this is uniform. As you can see here, there is a uniformity is maintained, that half section is here, half section is here. So total load will be divided, half by taken by RA and half will be taken by RB. So what is the total load? Total load. So suppose this is the load of this part is, suppose P, I am saying here total load is suppose P. So this is the half part is P by 2, which is shared by this triangle. I am showing only one triangle, another triangle is similar to this. So this is the one part. This total load is P. Suppose P is the total load, half will be shared by this triangle AC dash. So this is P by 2 half load, this is P by 2 half load. So out of this half load, and half will be here, half will be here in this triangle, P by 2. So total load is P, and P by 2 is half load shared in both the triangles. Both we have divided in two triangles here, two right angle triangles. So half will be shared by RA and half will be shared by RB. So out of total load P by 2 will be shared by RA and P by 2 will be shared by RB out of total load P, right? And total load is the conjugate beam is P. So what is the P, or why, what is P by 2? This P by 2 is the load of this part ACC dash, area of this part CCC dash. So basically P by 2 is, or you can see P is basically, if you take both the complete triangle, so this is half multiplied by base multiplied by height, right? So P will be equal to, P is basically the total load, that is half multiplied by base, total base is L multiplied by height. Height is WL by 4. WL by 4. So this will be equal to WL square by 8. So total load is WL square by 8 basically. And half will be shared by RA and half will be shared by RB. So RA will be equal to P by 2, which is equal to WL square by 16. And similarly RB will be equal to half of total load, that is equal to WL square by 16. Because the total load is WL square by 8, so half will be shared by RA and half will be shared by RB, right? And total load is P by 2 in downward direction. Total load is P by 2 of this triangle and P by 2 of this triangle, right? So this is the way that we have find out the reaction of this conjugate beam RA and RB. Now what is the slope? Slope is maximum at point A. So slope is maximum at point A. So this is theta max. And what is according to Mohr's first theorem for conjugate beam? The slope at A will be equal to the shear force of the conjugate beam at point A. Shear force of at A of conjugate beam, right, divided by EI, right? EI is the width of the beam is EI, right? So it is divided by EI by default. So theta max will be equal to theta max, or theta A will be equal to the load at A, right? And what is shear force at A? What is shear force at A? You can easily find out shear force at A. At A there is one load, that is P by 2. So this is RA basically. So this is basically RA, right? Shear force at A divided by the width of the beam RA, EI. So this is basically RA by EI. Because shear force at A is basically RA, and at A there is no other force, right? So we can simply write RA. So shear force, and you can find out the shear force at A, you will get the RA. So this is P by 2 to EI, and what is P? P is WL square by 8. You will get WL square by 16 EI. So theta at A, which is theta max, is this thing, right? So theta max is nothing but this is equal to WL square upon 16 EI. So this is the theta max. This is the theta max, right? Now we want to find out Y max. Y max occurs at C point. And what is YC? This is the moment at point C, MC, basically MC, moment at C. So YC, which is Y max, is the moment, bending moment at C of conjugate beam. We are talking about conjugate beam. So what is bending moment at C? Divided by EI, that is by default, that is divided by EI. So moment of this RA and moment of this P by 2. So this P by 2 has different moments. So moment about C. So bending moment taken to the left of the section. There are two forces to the left of the section. One is RA and one is this P by 2, right? And this distance will be, this is 2/3 here, this is 1/3 here. So this distance is 1/3 of total distance. This distance is, say, X. Say this distance is X. So X, keep in mind that X is basically, what is X? Here X is, I'm not saying X, you can say X bar, because it is a CG here, center of gravity here. So this is X bar, say X bar. So X bar is 1/3 of the total, 1/3 of the total length, that is L by 2. So that is equal to 1/3 of the total length, which is L by 2. Total length of this AC is L by 2, and 1/3 of that is X bar, right? So this is equal to L by 6, right? So YC is the bending moment at C of the conjugate beam. So YC will be equal to bending moment of this P by 2 multiplied by L by 2. So this is P by 2 multiplied by L by 2. This is positive, minus this is negative, P by 2 multiplied by L by 6. L by 6. So you will get, this will equal to, what is P? P is WL square by 8. So you will get WL square, it will become L cube by 8, it becomes 32, minus WL cube by 8, it will become 96. So 1 by 32 minus 1 by 96, so it will become 1 by, so YC, which is Y max, is basically, that is equal to WL cube by 48 EI. EI is divided by EI is always there, EI. So here I think we have forgot divided by EI. So this is P by 2 EI divided by EI also, right? So here we should write, that is P by 2 EI. Do not forget about EI. This is P by 2 EI, because the width of the beam is EI, conjugate beam is EI. So EI is always there, right? Here also bending moment at C of the conjugate beam. So when we say conjugate beam, it means it has a width of EI. So WL cube by 48 EI. So this is the maximum slope and maximum deflection for a simply supported beam loaded with a point load at the center, and we have obtained the maximum deflection, maximum bending, maximum slope using the conjugate beam method.